Alright guys, Coach Gu back here again with another fun-filled, action-packed, flipped geometry classroom video. And get hyped, guys and girls, because we're starting a new unit, Unit 5. This unit is all about triangle properties and attributes. We're going to be learning about all kinds of triangles because some of the world's best things are triangles. You know, you got Doritos, you got slices of pizza, you got other stuff that's shaped like triangles. So we're going to be learning all about triangles. And today, you can see at the top of the paper, we're going to be taking a closer look at isosceles and equilateral triangles. So yes, we're going to be starting with isosceles and equilateral triangles. Let's say that together. First, we're going to start with the isosceles. So isosceles triangle. Now let's take a look at the parts of an isosceles triangle. There's two, now count them, there's two congruent sides, and they are called legs. Now if you look at our diagram over here, you can see that we got the congruent marks, labeling that these two sides are congruent. So in our picture, which sides are congruent to each other? It would be AB is congruent to BC. You can see that in our picture. We've labeled it, okay? So that's the first thing of an isosceles triangle. The two congruent sides. There's always going to be two congruent sides, and they're called legs. Next, there's an angle. The angle where the sides intersect, that's where the angle where the two congruent sides intersect is called the vertex angle. Now, what angle on our diagram do the two congruent sides intersect at? If you said angle ABC or you said angle CBA, then you will be right. And we're going to kick it off right with a little high five up in there. Okay, next, the side opposite the vertex angle is going to be called the base. So let me label this real quick. I'm gonna use the green. The vertex angle, I'm going to label it's right here. Here's the vertex angle, okay? If that's the vertex angle, and the side that's the opposite of the vertex angle is called the base, which side is the base? In our diagram, it would be AC right here. That's the base because it's the opposite of the vertex angle. All right, and then finally, the angles along the base. The angles along the base. So in our picture, that's angle 2 and angle 3, but I'm going to label it with 3 letters just so we can get that practice in so we know how to label it. It could be angle BAC and angle BCA. These two angles right here, boom and boom, are called the base angles because they lie along the base. So there it is. We've got our two congruent legs. We've got the vertex angle where the congruent legs intersect. We've got the side that's opposite of the vertex angle called the base. And we've got the angles along the base called the base angles. So now let's take a look at two special theorems of isosceles triangles. Let me clear this page out. Boom. All right, so first we've got the isosceles triangle theorem. If two sides of a triangle are congruent, so let's look at our diagram. If two sides of the triangle are congruent, then the angles opposite those sides are congruent. So look at the two sides in our diagram. Once again, it's going to be AB and BC. These two sides are congruent, right? So then there are two angles that are opposite. So I'm just going to call it by number, but angle 2 right here is opposite of side BC, right? And then which side is opposite of AB? That's angle 3. So that's right. And these two angles will be congruent, okay? That's the isosceles triangle theorem. So for example, in our picture, we've got if, let me write this in a fancy little statement. If, we're looking at our diagram here, if AB is congruent to BC, because that's what we have in our picture, then angle A, I'm just going to use the letter here, okay? Angle A is congruent to angle C. okay? Or I'm gonna show you also with the 3 letters. Angle BAC is congruent to angle BCA. So that is the isosceles triangle theorem. Make sure you remember this definition because we're going to be using it a lot. And next, we've got the converse of isosceles triangle theorem. What's the converse? What do we do with the converse, boys and girls? The converse, if the isosceles triangle theorem is if P then Q, then the converse is if Q then P. So instead of saying if AB is congruent to BC, then angle A is congruent to angle C, we would say if angle A is congruent to angle C, then what? AB is congruent to BC. Bam! There it is. And if you read our statement, read the statement for the converse of isosceles triangle theorem. If 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. So in our picture, take a look right here. Angle 2, whoa. If angle 2 and angle 3 are congruent, then the sides opposite those angles, that's going to be sides AB and side BC, will be congruent. And that is the converse of isosceles triangle theorem, and this is always true as well. All right, so that's all we're going to be knowing about isosceles triangles for now. Let's go and do some practice. Scoot it down. We're going to apply our knowledge of the sides and angles of isosceles triangles to do these examples. So here we go. Number 1, take a look. Find each missing measure. We're only doing this with 1 now. So measure of angle J. Well, look at here. Here's J. Boom. Measure of angle J. Which angle is angle J going to be congruent to? Angle L. Because of the isosceles triangle theorem. Remember, these 2 sides are congruent, then the angles opposite the sides are also going to be congruent. So measure of angle J is also going to be 68 degrees. And now I need to find the measure of angle K. How am I going to find that? Well, the total in a triangle is 180. So I can add up these 2, angle J and angle L. That's 68 plus 68. That's 136. And so now I can subtract that from 180. 180 minus 136 is going to be 44. So 44 degrees is the measure of angle K. On to the next one. Number 2. Look at this. This time they tell us that D is 106 degrees. And C, we know C and E must be congruent because they are the angles opposite of the congruent sides. So if they're congruent, how am I going to find their measures? We're going to do 180 minus 106 because D is 106. So we don't need that part. That's going to leave us with 74, right? We got 74, and C and E are congruent. That means they're the exact same. So if I have 74 degrees left, I'm going to divide that by 2, and that's going to give me each of the angles. So divide by 2, it's going to be 2, 6, 1, 4, 27. So both C, no, whoa, what am I doing? Hello? Hello? Question mark? It's going to be 2 divided into 74, 3 times 6, 1, 4, 7, 37. So measure of angle C and measure of angle E are both going to be 37 degrees. And if you check yourself, the total angles need to add up to 180. So I can add 37 plus 106, and that should equal 180. If it's not, then I did it wrong. All right, on to number 3. Whoa, this time they didn't label the congruent sides, but they showed me that there's congruent angles. Look, 77 degrees right here, 77 degrees right there. What does that mean? Remember, the converse of the isosceles triangle theorem says if the 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. Which sides are opposite? So that's going to be this one and this one. So if XY is 12 centimeters, what's YZ? YZ is also going to be 12 centimeters. Whoa, that's one of my answers. And now, how am I going to find the measure of angle Y? That's over here. Well, if X is 77 and Z is 77, then y is going to be, I'm going to add the 77s together, plus, it's going to be 4, 154, and then I'm going to subtract that from 180, minus 154, 26, and measure of angle y is going to be 26 degrees. All right, on to number 4. So we're going to find the value of each variable. This time we're using a little bit of algebra to do the same things that we've been doing. So take a look at this, where they've gave us two congruent sides. The isosceles triangle theorem, what does that thing say? It says that the angles opposite of those two congruent sides are congruent. So where are the angles that are opposite? Boom, right there, and bam, right there. So these two angles are congruent. So what's my equation gonna be? It's gonna be 5x plus 9 equals 8x minus 30. Now let's solve this using algebra. Subtract 5x from both sides. Boom, boom. That's 9 equals 3x minus 30. I'm gonna add 30 to both sides. Plus 30 plus 30. And that's gonna give me 39 equals 3x. Finally, I'm gonna divide by 3 on both sides. And then, so x equals 13. And I got my answer. Now we're gonna do number 6. Oh, I skipped number 5, so what does that mean? What does that mean? That means you're gonna try number 5. So let's go to number 6 first though. Number 6, oh, they labeled a pair of congruent angles. So by the converse of the isosceles triangle theorem, these two sides, these opposite sides, bam, they're gonna be congruent. So what's my equation here gonna be? It's gonna be 15x plus 7 equals, what do you 23x minus 17. I know you said that because you knew it, right? We're gonna subtract 15x from both sides. Boom, boom. That gives us 7 equals 8x minus 17. We're gonna add 17 to both sides. Boom, and then 24 equals 8x. Finally, I'm trying to get this x by itself, so I'm gonna divide it by 3. Get that 8, get off my x, that's my, wait a second, that sounds funny. Okay, 24 divided by 8 is 3, so x equals 3. Boom. So now you guys are gonna try 5 and 7. You can look back at these for reference, but try 5 and 7, and then want to come back as a class and check it all together. Make sure we did it right. All right, moving on. We're doing numero 8. So check. Oh, it's a word problem. My favorite. Coach Goo, I love word problems. Thank you. I had to make this though. All right, so number 8. In triangle RST. Bam, boom, shkabap. R, S, and T. If RT is congruent to ST, let's label that RT is over here and ST is over here. Okay, there's my two congruent sides. Now, what else do we know if these two congruent sides, which angles would be congruent? Angle TSR is over here, and angle TRS would be congruent as well because of the isosceles triangle theorem. Just to give you a little visual where the opposite angles are. Okay, now let's continue reading. If the measure of angle R is 9x plus 2, so R right here, boom, 9x plus 2, and the measure of angle S is 13x minus 18, so this is 13x minus 18, and the measure of angle T, that's right here, is 17x plus 1, find x, and then the measure of each angle. Well, what equation could I set up to find x? That's going to be, we're going to put the two congruent angles, we're going to set those equal to each other. So measure of angle R is congruent, is equal to the measure of angle S. So my equation can say 9x plus 2 equals 13x minus 18. We're getting back into algebra, and I love it. All right, so let's subtract 9x from both sides. Boom, boom. That gives me 2 equals 4x minus 18. Then I'm going to add 18 to both sides. Bam. That gives me 20 equals 4x. So finally, if I'm trying to get this x by itself, get that 4 out of there. You ain't messing with the x. And then that's going to be x equals 5. So x is 5. Now, if I'm just trying to find the measure of each angle, all I got to do is take this x right here, that 5, and plug it back into each one. So for measure of angle R, it's going to be 9 times 5 plus 2. For measure of angle S, it's going to be 13 times 5 minus 18. For measure of angle T, that's going to be 17 times 5 plus 1. So let's see what we get. So measure of angle R, 9 times 5, that's 45, plus 2 is 47 degrees. Do I even need to do the math on measure of angle S? No, because it's the congruent to angle R. It's the exact same thing. That's the isosceles triangle theorem. So it's going to be also 47 degrees. And then finally, how am I going to find measure of angle T? I could plug in this 5 and find it, or I could just add 47 and 47 and subtract that from 180, because remember the total is 180. So let's take a look. 47 plus 47, that's going to be 194. 180 minus 94 is 86. So the measure of angle T is 86 degrees. And if you add these three numbers together, it's going to be 180 degrees, because no matter what kind of triangle you have, the total degrees in that triangle is going to be 180. All right, so with that one done, we want you guys to try numbers 9 and 10. Go ahead, take a little try on 9 and 10. All right, now that that is done, we're going to move on. We got one more to learn about. Today, we're going to be doing equilateral triangles. So guys, let's take a look at equilateral triangles and see what they are. Do you guys remember what equilateral triangles? A triangle is equilateral if and only if it is what is that word? Equiangular. Equiangular. That means that all the angles are equal. So take a look. If measure of angle A equals the measure of angle B, so I'm going to label it on my thing. Measure of angle A equals measure of angle B. Those two are congruent. Equals measure of angle C. Then what does equilateral mean? Equilateral means all the sides are the same. Then that means AB equals BC equals AC. Look, AB congruent to BC congruent to AC. All three sides are congruent. All three of the measures are the same. All three angles are congruent. All three measures are the same. So then also, if AB equals BC equals AC, so if the three sides are all the same, then what are we going to say about the measures of the angles? Then measure of angle A equals measure of angle B equals measure of angle X. No, just kidding, C. Measure of angle C. All right, so let's do some examples with the equilateral triangles. Remember, on equilateral triangles, all the sides and all the angles got to be the same. They're equiangular and equilateral. Let's take a look at number 11. So first of all, wait, we got a missing angle here. That's not going to help me, so let's find this angle C right here. If B is 60 and A is 60, how am I going to find C? I'm going to add B and A together and subtract that from 180, because the total should be 180. So let's see, 60 plus 60, that equals 120. And then I'm going to go 180 minus 120. What do you know? C is also 60 degrees. That means all three angles are the same. They're equiangular. So that means all three sides are, oh, let me write that in here. Boom, 60 degrees. All three sides is equilateral. They're all the same. Boom, congruent. So BC is going to be 9 feet. AC is also going to be 9 feet. Now think about this. Let me riddle you this. Think about this for a second. If there are 180 degrees in a triangle, and an equilateral triangle, every equilateral triangle, all the measures of the angles are the same. There's 3 angles in a triangle. There's 180 degrees total. In any equilateral triangle, what does the measure of the angles have to be? It's gonna be 60, right? Because there's 180 degrees total to mess with, and there's always 3 angles, 3 is going to be 60 all the time. In any equilateral triangle, each angle is 60 degrees. So look at number 12. They're telling you the 3 sides are congruent. That means you know it's an equilateral triangle. If it's an equilateral triangle, how would I find the degrees? It has to be 60. It's got to be. So 60 degrees, 60 degrees, 60 degrees. Boom, there it is. Because the 3 sides are all the same, we know it's an equilateral triangle. And equilateral triangles, all the angles have the exact same measure. And the only way that's possible is if they are all 60. You guys are going to try this one on your own. I want to challenge you guys a little bit. Look, there's X and Y. So try that one. We're going to check back with your teacher. But that's going to be in the end of this video and the start of Unit 5. So until next time, guys, see ya. Peace.